For decades, astronomers believed that the earliest chapters of the universe were forever beyond our reach, hidden behind immense distances, billions of years of cosmic history, and the limitations of even our most powerful telescopes. The first stars, the earliest massive stellar systems, and the moment when galaxies first began to take shape seemed destined to remain subjects of theory rather than direct observation. Then the James Webb Space Telescope delivered an image that quietly changed that assumption. In a single observation, Webb revealed dense clusters of stars so ancient and so distant that they may represent direct survivors from the universe's earliest era. These were not faint smudges at the edge of detectability or abstract theoretical predictions. They were massive, compact stellar systems containing millions of stars, observed nearly 9 billion light-years away around a strangely distorted galaxy that astronomers nicknamed Spark. With this remarkable observation, Webb uncovered evidence suggesting that some of the universe's earliest stellar structures may finally be within observational reach. What astronomers detected was more than distant starlight. It was history itself, preserved since the era of cosmic dawn. The discovery immediately raised one of the most profound questions in modern astronomy. Are we finally seeing the surviving remnants of the first generations of stars ever formed? Using the extraordinary sensitivity of the James Webb Space Telescope, astronomers identified what appeared to be the most distant globular clusters ever observed. These compact stellar systems, each containing millions of tightly bound stars, lie approximately 9 billion light-years from Earth. Globular clusters are unlike ordinary groups of stars. They are ancient stellar cities that formed during the earliest stages of galaxy assembly and have remained gravitationally bound for billions of years. The clusters discovered by Webb are remarkable not only because of their immense distance, but because of what that distance represents in time. Observing them means looking back to an era when the universe was still relatively young and galaxies were only beginning to assemble their modern structures. These clusters may preserve information from some of the earliest generations of stars, offering an exceptionally rare glimpse into conditions that existed shortly after the first large cosmic structures began to emerge. Their enormous mass and extraordinary compactness suggest that they formed rapidly and efficiently during a period when the universe was dramatically different from the one we observe today. Until now, globular clusters at such extreme distances had remained completely beyond the reach of direct observation. The scientific importance of these distant globular clusters lies in what they now allow astronomers to investigate for the very first time. Because they are massive, ancient, and relatively simple stellar systems, they serve as natural time capsules preserving the conditions of the early universe. Researchers explain that these clusters may contain some of the universe's oldest stars, or at least stars that formed shortly after the first stellar generation. Before the launch of the James Webb Space Telescope, astronomers simply lacked the ability to study globular clusters at these enormous distances with enough precision to measure their physical characteristics. Now, by observing them across multiple infrared wavelengths, scientists can begin estimating their ages, analyzing their stellar populations, and determining approximately how many stars each cluster contains. These measurements open an entirely new window into understanding when the earliest stars formed and how the first galaxies assembled their stellar mass. Instead of relying exclusively on computer simulations and theoretical models, astronomers now possess direct observational evidence from a period of cosmic history that had previously been inaccessible. In that sense, these globular clusters are far more than distant collections of stars. They are fixed reference points in time, helping researchers reconstruct the earliest stages of galaxy formation and cosmic evolution. When the first high-quality scientific images from the James Webb Space Telescope were released, astronomers immediately noticed one particularly unusual galaxy. Among countless distant objects, it stood out because it looked unlike any ordinary galaxy. Rather than appearing symmetrical, it looked stretched, distorted, and almost torn apart. Surrounding it were numerous compact yellowish-red points of light that resembled glowing sparks frozen in space. This striking appearance earned it the nickname Spark Galaxy. What first appeared to be a visual curiosity soon became the focus of intense scientific investigation. The distortion was not random, and the compact objects surrounding the galaxy were not unrelated background sources. They were physically connected to the galaxy itself. Located approximately 9 billion light-years away, Spark is observed as it existed billions of years ago during one of the most critical periods of galaxy evolution. Its elongated shape suggests the influence of powerful gravitational forces, while the compact stellar systems surrounding it hint at something even more significant. This galaxy appears to host massive ancient stellar systems that formed remarkably early in cosmic history. A team of Canadian astronomers concentrated their investigation on these compact objects surrounding Spark, carefully analyzing them across multiple wavelengths using Webb's powerful instruments. Their findings proved extraordinary. Among the numerous bright points encircling the galaxy, researchers confirmed that 5 were genuine globular clusters, massive, ancient stellar systems containing enormous numbers of tightly packed stars. These were not young star-forming regions or random concentrations of light. They were fully developed globular clusters and potentially the most distant examples ever identified. The lead researchers expressed their surprise at discovering such remarkable objects so early in Webb's mission. They noted that many of the bright sparks surrounding the galaxy's main body were, in fact, massive and ancient stellar systems rather than ordinary background objects. This discovery transformed Spark from an unusual-looking galaxy into one of the most valuable natural laboratories for studying the early universe.